These are the notes for Thursday, and our end game in this is to be able to integrate some expressions that involve the inverse trig functions. In section 5.6, if you have notes for that, and if you were to go open it up, you would see this part of it, but I want to revisit deriving your inverse trig functions before we try to inverse some expressions that involve the inverse trig functions. So you might remember that the derivative of arcsine and the derivative of arctangent are very similar. Those are two I had you commit to memory for the AP exam. So we'll put those on our little table down here, that the derivative with respect to x of arctan, remember that was the prettier one, and I'm going to call it arctan u, so u as usual is a function of x. If you remember, that was nice because it didn't have a root and it had a plus. They all have u prime on the top, and if u is x, they all have a 1 on the top. Similarly, the derivative with respect to x of arcsine u is u prime over the square root of 1 minus u squared. Those two you should be comfortable with because we've done them before. We did the other 6. I just didn't have you commit them to memory. So we'll put secants on here. We'll write equals, and then I'll derive it for you. So back up to the top. Yes, I had you memorize them, but I like you to see where they come from. So we're going to take a moment and rederive these. If y is arcsine x. And remember, my problem is I'm trying to take the derivative of arcsine, but I don't like arcsine. So my first line of business is going to be to get rid of it. And I'll perform its inverse operation. It's kind of like if you want to get rid of x squared, you square root. If I want to get rid of arcsine, I will sine both sides. The sine of arcsine x is just x. This gives me a picture for this situation. I have some angle y whose sine is x. Sine is opposite over hypotenuse using SOHCAHTOA. So I know the opposite has to be x and the hypotenuse is 1. So it gives me a visual of the right triangle that goes with the situation. The reason I took the sine of both sides is because I can find its derivative. So I'll take the derivative of the left-hand side is equal to the derivative with respect to x of the right-hand side. The derivative of sine is cosine. But remember, I don't have a variable match here, so I really am considering y as a function itself. So I do cosine y times the derivative of the guts. The derivative of x with respect to x is just 1. So now I'm able to attack y prime, and that was my goal. Y was arcsine, and I want to figure out its derivative. So I have y prime equaling 1 over cosine y. To figure out what cosine y is, I consult my right triangle. Cosine is adjacent over hypotenuse. So I need to get this adjacent leg by using the Pythagorean theorem. When I do that, I'd say it squared plus x squared is 1. So it is 1 minus x squared's square root. And that becomes my new denominator. And you'll notice that that's exactly this. It was u prime, where u is x. So it was 1 over 1. I forgot to square root it, sorry, over square root of 1 minus u squared. Again, I did it with just x, and had I called this u and u and u, then I would have replaced my du dx right here with a u prime. So it's just, this is a specific case where I just have x. So doing a similar with arctan, my goal is to figure out its derivative. I don't know its derivative, and I don't like dealing with the inverse trig function. So I'll get rid of it by taking the tangent to both sides. And again, we did this in chapter 5. I'm just revisiting the derivatives because it'll help us integrate. I have the tangent of some angle now equaling x. So I consult my right triangle. Tangent is opposite over adjacent. It must be x over 1. Now I'll take the derivative with respect to x of both sides of the equation, and that will give me 1. The derivative of tangent is secant squared, so we have secant squared y times y prime is equal to 1. Remember, my goal is to figure out the derivative of arctan. My goal is to figure out what is y prime. In this scenario, y prime will be 1 over secant squared y. So my goal is to figure out what is secant squared. It's the reciprocal of cosine, and cosine is adjacent over hypotenuse with my SOHCAHTOA. So secant is hypotenuse over adjacent. So I need to find that. And I say a squared plus b squared is equal to c squared. So when I put that down here for secant, and then I square it, I get my nice tangent derivative. You could do arcsecant the same way. I'm not going to go through that one again. I'll just tell you what that one is. So you'll notice that they're all very similar. Let's go do this. They all have u prime on the top. And if u is x, they all have a 1 on the top. The only difference with the cofunctions is that if I had a cotangent here instead, I end up getting negative u prime over 1 plus u squared. And it comes from the fact that the derivative of cosine is negative sine, so that's kind of what causes that. If this had been cosine u, same thing. I would get the exact same model just with a negative. So the only one I don't have on here is secant and cosecant, and we could derive it in the same way. But again, it's going to have the u prime on the top and a negative u prime on the bottom. On the denominator, it has a u, and it has the square root of u squared minus 1. And we're not going to use that one anyway, so it doesn't really matter. So now, the section I skipped when we were doing these was section 5.7 in our text. We quit at 5.6 and moved on to the next chapter. 5.7 was integrating when it involves inverse trig functions. We didn't skip it because it was difficult. We skipped it because I knew you wouldn't be asked to do it until your Calc BC exam. So, this just says, what do you think these are? This is very in your face. If you were to try this with u sub, it wouldn't work, but you should recognize this. I'm asking you the derivative of what? It gives you 1 over 1 plus x squared, and that's straight up, you can't show any work. That's arctan in its most naked form, with u being an x, and it's u prime 1 over 1 plus x squared. This is arctan x plus Carl, straight up. There was nothing I needed to tweak or work on with it. Had that been a 5, I would have had 5 arctan x plus Carl. Much along the same lines over here, this is just one of them in your face. It's the derivative of what gives you 1 over 1 minus x squared, and I can see it right here. That's arcsine's derivative that I'm integrating, which means this would be arcsine of just x plus c. And again, if I had a 3 on here, it'd be 3 arcsine x. This is where you have to be careful. If I had a 3x on here, that's no longer triggy. That actually goes to u sub, which we'll talk about on another page here coming up. This page has a typo, so get rid of that. That should be a minus on there. So the difference is if we don't have our function being just x, if it's some function of x, like maybe it's x squared or something like that, if we can get it in this model, we can still use our inverse trig functions. It says we're going to prove these in Calc 2. We're actually going to prove them tomorrow. Their proofs are rather involved, so today you're just going to use them similar to when you learn the quadratic formula. They just tell you what it is, and then you use it. So I'm going to tell you what these are, then we're going to use it, and then tomorrow we'll prove them. So if you have something set up like this, and you're looking at it, and you're like, that looks an awful lot like arcsine, it is. Your answer is going to be arcsine. But instead of x, right, I'm going to throw one over here so you can see what I mean. Maybe this was 1 over du, and I had a square root of, let's say, 9 minus 4x squared. Again, normally I would try some u sub, and I'd let u be that inside function. Its derivative is negative 8x, which isn't living in the rest of my integrand. So this is looking quite a bit like it's in a form that would use arcsine. I've got this root, I've got this minus. This is not a 1 though, and this is not an x. However, it's kind of very Pythagorean-ish. It's something squared and something squared. And when that happens, this is still arcsine. It's just we say it's arcsine u over a plus c. So over here, my u would be, what did I square that was a function of x? And the answer would be 2x. My A would be what did I square to get that lead number? And the answer would be 3. So you might be thinking, okay, that's just arc sine 2x over 3. It's really close, but I have to generate this du. So there's still some fraction correction that goes on with this because right here, that dx is not equal to du. I can't just tack on a du there. I have to tack on a 1/2 du. So be very careful with that, let's point over here, that you need to generate your du before you think you're done. That's the most common mistake, is just throwing it into the model and forgetting that you have some du to work with. So that one would have been actually 1/2 arc sine u over a. A couple of years ago, they came up with a way to remember this because a lot of them were in anatomy at the time, and somebody, I don't even remember who it was a while ago, said they do u over a, they think urine analysis, which sounds kind of dumb, but it sticks in your head. Likewise, with arctan, it's really similar. The only difference is it's 1 over a arctan u over a. So we say 1 over analysis arctan urine analysis. It seems dumb, but it sticks in your head. So your goal with these is to, first of all, you always try u sub. If it fails you, you should keep your eye out for these models that look very Pythagorean-y, like you're squaring things and adding and subtracting them. Those lend themselves to these inverse trig functions. So over here I have a typo. This should be a 1. This right here, if I tried u sub, I'd let u equal 1 minus x squared. Its derivative is negative 2x dx. That's not helpful. I then will recognize that this looks very much like arc sine. I need to identify my u. I need to identify my a, and this is just arc sine u over a. This is arc sine in its cleanest, most naked form, so really that wasn't necessary, but I wanted to show you it. Again, it didn't need a fraction correction because du in this scenario is 1 dx, so be careful. Next one. It looks a lot like example 1. It just has a couple variances on it. First of all, I have a 5 on the top, so I'll do what we always do when we have a constant in our integrand and pull it out front. Again, I'd always try u sub. It's the biggest integration tool you have. It won't work here, but if this was an x on the top instead of a 1, u sub's my man, so be careful with that. Again, this is looking like arc sine. I need to identify my u. In this scenario, it's what function's being squared, and that's an x. I need to identify du to see if I have a fraction correction, but in this scenario, du is dx, so no need to do a correction on that. My a is whatever number's being squared out front, which is a 2, and then I'll just say this is 5, the one I pulled out front, arc sine urine analysis, plus Carl, and it's done. Example 3, negative 2 will come out front. I'm integrating 1 over 1 plus x squared dx. This one is screaming arctan, and it's arctan in its most naked form, where your function is x, its derivative is dx. So this is really nice. This is just negative 2 arctan. And if you want to think of it as urine analysis, 1 over a arctan urine analysis, it'd be 1 over 1 arctan urine analysis. It still works itself out. This is the most common one we get in Calc 2. They need to spot that one a lot as being arctangent. Sometimes there'll be like a different number up here, and that's 4 arctan 1 plus x squared. But I would say of all of them, just that naked form of arctan is the most common. Next page. Sorry about that. Example 4 and example 5 are almost identical. The only difference is the numerator. It makes a huge difference in how we execute the problem, though. One of these is arctrig, if that's a word, and the other is u sub. So always think u sub. It takes 2 seconds to do it in your head. If u is this, du is negative 4x dx. That's not living in the numerator. But on this one, if u is 5 minus 2x squared, du is negative 4x dx, and I really do have the rest of that integrand in my du. If I just fraction correction it, this is not triggy at all. This is the integral of x dx is negative 1/4 du all over root u. That's really what that is. So that fraction correction of -1/4 would be out front. It'd be u to the -1/2 du. This is not a new topic over here on number 5, but number 4 is vastly different. So you really have to be careful. Sorry about that. -1/4 u to the add 1 to the power, divide by that power, tack on a Carl. So number 5 ends up being -1/2 square root. Who was u again? 5 minus 2x squared plus c, lock and load it. This one should have been able to do any time since November. Over on number 4, you would get stuck if I didn't teach you anything new since November. The u sub does not work. It's obviously not set up for biparts. It's got one algebraic function, but it's looking very Pythagorean-y up here. I have a square root. I've got something squared in there. It looks maybe like it will lend itself to being arcsine or arctangent. This one's arc sine. I need to identify the function that's being squared. That's my u. So right here, it'd be x, but it'd be a root 2x. If I square that, I'll get 2x squared. My a is what's being squared to give me this. So a is root 5. Next step, I'm going to launch into my model. It would be arc sine u over a. There's just urine analysis. You don't need to rationalize the denominator, but I purposely made a mistake, and it's the most common mistake. And I would like you to kind of hopefully anticipate what it was. I just replaced that. I said, okay, that's 1 over the square root of a squared minus u squared du. I just swapped these out, and I went right to the model. Again, you can't do that. You need to generate du right here and recognize that you can't just replace dx with a du. You need to replace it, you need to replace it with a 1 over root 2 du. So this one needed a correction in front of it. So again, be careful with generating du and not just swapping it out. All right, second to the last one, number 6. Maybe you're thinking inverse trig because you see this squared 3 and you see the plus and you're thinking arctan, but this doesn't work because remember I need to have some function squared sitting here and I don't. This is u sub. This is u being 9 plus e to the x. This is du being e to the x dx. This is just a really basic u sub. When I'm all done, that is just 1 over u, and the whole rest of it is du. This is natural log, absolute value, u plus c. Now, I'm going to tweak it and make it inverse triggy with the least amount of tweaks possible. So if I want to make this, you really understand it if you can morph it into something that fits my new model. It means you understand the new model. If I wanted to make this be so that you had to think inverse trig, I would want you to think tangent because that's the one it's closest to. I'm fine with the 9. My a could be 3, so I wouldn't have to tweak it. I'm fine with the plus. That's in arctan's model. I don't like this. I need to have a function squared. Might as well make it e to the x squared, which is e to the 2x. Now, in my scenario, my u, in this case, and again, this isn't like the u as in u sub, this is u in the inverse trig model. My u would be e to the x, so that I have a squared plus u squared. My du would be e to the x dx, so the most logical, easy thing for me to put on here so that this becomes inverse trig is that. Then, if you were to perform this using the model, this is now in the form u prime, where u is e to the x, over a squared, where a is 3, du. And there's no fraction correction because the derivative of u is e to the x, and that's what's sitting up here. So this is 1 over analysis, arctan, urine, analysis, plus Carl. And we'll prove that model to you tomorrow. For now, I just want you to spot the inverse trig and execute the inverse trig. You don't need to understand why it works that way yet. Number 7 is the last one and the most difficult one. Again, u sub's my go-to. I would think letting u be 4 minus 2x squared. Its derivative is negative 4x dx. There's no way I can generate that numerator. It's looking a little arc-siny, but that plus in there is causing an issue. So when I say that plus in the numerator or the addition is causing an issue, then you might want to get rid of that issue. And I would say that if that was a 3 plus 2 over the square root of 5, you should recognize that you can break that up. It would be 3 over the square root of 5 plus 2 over the square root of 5. That's what I could do over here to get rid of that addition that's bothering me in the numerator. What I have now is two integrals, one of which is inverse triggy and one isn't. Now, I would challenge you, if you were in class today, I would have asked you which one is the inverse trig one. And the answer to that is this one. This one over here is u sub. And look how similar they are. They're very, very similar, but very different. On this one, I would launch into u sub, and I would have a negative 1/4 fraction correction and a u to the negative 1/2, blah, blah, blah. I'm confident you could do it from there. On this one, if I tried to launch into u sub, again, I've got the issue. I don't have any x in the numerator. So then this is where I start to think, okay, this is looking really a lot like arcsine. I'd have 2 out front. I'll put the 1 on here. This is the square root of a squared minus u squared, but I have to generate du. So in this scenario, oops, I said a squared and I wrote 4 squared, sorry. See if I can get that out of here. My u in this choice, again, it's not the same u as in u sub, so u is kind of used a lot. My u in this scenario is what got squared here. That'd be a root 2x. My du is a root 2 dx. So in addition to the arcsine model, I will also have to insert my own fraction creation when I generate and replace dx. I will be replacing with a 1 over root 2 du, just so you have that down. Now I'm ready to do the model. This would be arc, sine, urine, analysis. Who's analysis? What's my A? It's a 2, right? And then I also have the 2 out front that I pulled because it was part of my constant. And then I also need to have my 1 over root 2 fraction correction. And then plus Kyle, and we're done. The assignment was the worksheet 1 through 10. There's only one on there that's not inverse triggy. So there's one u sub problem on that paper. You'll miss it if you don't kind of run it through your head on all of them. And that's it. Peace out, Girl Scout.